Hello. So today we are going to do a little bit more with lesson 1.1. So we have these 9 graphs here, and the main one you're going to look at for today is the far left because that is the position and time graph. So if you look at it, you can see that the y-axis says x, and x in this case is just meaning position, so the distance. And the x-axis is labeled with a T, and that is for time. So it's really a distance time graph that you have seen in math class. It's just written a little bit differently. What do you have to definitely make sure when you're in science to write the units, because we need to know what scale we're going on. And in physics, often you're going to have meters here. And your time often is going to be in seconds, just not always. So always be aware of that when you're looking at it. And again, this is just the first column. And how do you remember which one's which? I think of it as time marches on, okay? Because time, if somebody's marching, they're on that level horizontal surface. And just remember that that is your independent variable. If you want to know the acronym to help you remember that, dry mix, dependent, and it's on the y-axis. This one is manipulated, so it's independent, and it's on the x-axis. And so there we have that information. So what else can we get from this graph? If we take the slope of it, we get speed. So this one here is labeled as object at rest, but you would actually know that this is a horizontal line. So the slope is 0. And so the speed is 0. And does that make sense? Yes, because we are at the same meters away each time. So whatever this is, 1.5, 550, it doesn't matter. That distance away from the origin is not changing. So the object is at rest, which just means not moving or stationary, either way that you want to look at that information. And just as a reminder, if the line was completely vertical, that's when you would have undefined. So now what's our second graph? If we look at it, the tick marks here are about the same distance apart for X and Y. They're not always, but in this case, that's going to help us out because we're traveling 1 block up and 1 block over. And then the next graph is, the next point is 2 blocks up and 2 blocks over. So what's that saying? For the same change in distance happens at the same time. And whenever anything's the same, we're going to use that word uniform. Uniform, it is the same. So as we're going through this object, it's not slowing down or speeding up. It is going at the same speed the whole time, the same distance per time, the same distance per time. As it goes up, it's still changing the same distance per time. So it's at the same speed. Okay, so we call that constant speed, or in this case, velocity. That's just speed in the vector quantity. We'll talk more about that tomorrow. Okay, and uniform motion. So anytime you see a line that is not horizontal or vertical, it is going to be at constant velocity if you're on a position time graph. So in physics, it's really careful, be really careful and look, what graph am I talking about here? What is this? Is it a line, straight line? Is it curved? What's going on here? So really look super carefully. We're not doing these other 2 columns. I just wanted to show you that sometimes the change does not look super different, but the graphs mean totally different things. And this guy down here, it's curved. Anytime you see a curve, that means that it is variable or not uniform. Okay, so it's not staying the same. So at this little first part here, we're going slowly speeding up. So if you can think about it in a car, the light just turned green. You're not putting the pedal all the way down. You're slowly increasing. And then maybe you're gotten a little comfortable distance away. And now you're going to be speeding up a little bit faster. You're getting a greater distance change for the same amount of time. So this guy is speeding up as he goes on. And at some point, it may change to a straight line where they have constant speed. They put on that cruise control. Okay? And so here we go. This guy is going up. So we know we're accelerating. We're speeding up more distance per time. If the curve was going the other way, then it would be less distance as we go on per time, and that would be decelerating. So sometimes these graphs look weird and people want to come through and figure out more information. Just start with the simple stuff. Look at each part and break it down. And first, confirm, is it a position time graph? Position is talking about distance. Okay, and here my distance is in miles. Is miles a unit of length? It is. So you can go, yes, it is a position. And this one's minutes, so it is a position time graph. So what do I need to remember for that? The slope is going to be what? The slope will be the speed or how fast something is going. You notice they have different scales here. That's okay. You just have to be aware of it. So in 0.5 miles, may only take about half a minute or 30 seconds. So just look at it super clearly. They could ask you for what's happening at minute 5. A minute 5 right here, we've gone 2 miles, but are we moving right now? Nope, we're not moving right now because we have that flat line segment. So break down each part. So what is line segment 1 telling us? The distance and the time are increasing, and they're increasing at the same rate because it's a straight line. It's just not straight horizontal or straight vertical. So we have uniform speed, and it goes from 0 miles to 2 miles, so a total of 2 miles. Sometimes your graph doesn't start at 0, so just again, read carefully. What's line segment 2? No distance change. So as we said, that is at rest, and it's at rest for 6 minutes, not 8 minutes. Okay, it ends at 8 minutes, but it's at rest from 2 minutes to 8 minutes, so 6 minutes total. And that last line actually looks at the same slope as the first one, so it's the same thing. Uniform speed for a total of 2 miles. And so we know that the first line segment and the last line segment are going at the same speed. So this could be you going on the highway, and then you stopped at the restaurant stop to get some food and some coffee before you continued on your trip. So we're going further and further away from our origin. And we took a total of 4 miles for this graph, and it took a total of 10 minutes, but only 4 of those minutes were in motion. So that's how you kind of want to break down all these graphs, is just look at each part carefully. And that's just your quick snapshot for today. So I will see you tomorrow.